Okay, so if we look here, we'll just call this sequence AN, and we should note that clearly AN is a positive sequence. Now, we shall let Bn equals 1 over n cubed, and we note that Bn is also a positive sequence. Okay, let's calculate the limit of An over Bn. So this divided by this would be n5 plus n cubed over n power 5 plus n plus 1. So dividing by Bn, which is 1 over n cubed, is like multiplying by n cubed. Oh, limit as n goes to infinity. So let me just squish that in. Limit as n goes to infinity. That would be the limit as n goes to infinity. If I divide everything by n power 5, that's 1 plus 1 over n squared, 1 plus 1 over n power 4, plus 1 over n power 5, which is 1 plus 0 over 1 plus 0 plus 0, which is 1, which is more than 0. So when An is positive, Bn is always positive, and this limit here is positive as well, we can use something called the limit comparison test, which says that the sum An and the sum Bn converge or diverge together. So now we just have to look at the sum of Bn to know what will happen for the sum of An. That's the sum of 1 over n cubed. And then by the p-test, the p is more than 1, just the power here, for 1 over np sequence. That would mean then that this is convergent, and therefore, since it converges and diverges together, that means the sum here is also convergent. So we conclude that this is a convergent series.